Knit lines or weld lines are one of the most common defects in injection molding, occurring when molten plastic flows around obstacles like holes, inserts, or complex geometries and fails to fully merge before cooling. These visible seams not only compromise the aesthetics of the product, but also weaken its structural integrity. For industries requiring high precision, such as automotive, medical devices, or consumer electronics, knit lines can lead to part rejection and increased costs. We can effectively prevent the appearance of knit lines in several ways. Optimize the gate position of the mold. Strategic gate positioning place gates closer to potential knit line areas to ensure uniform flow front merging. For multi-cavity molds, balance gate layouts to avoid flow path disparities. Multiple gates. Use multiple gates to shorten flow paths and reduce temperature differences between melt fronts. Gate size adjustment in large gates to lower flow resistance, especially for high viscosity materials like PEEK or reinforced nylon. Optimize mold exhaust design. Adequate venting is critical. Trapped gas in the mold cavity can lead to the formation of fusion lines. As the melt flows through the cavity, if it encounters gases that cannot be expelled, gas pockets will form where the melt fronts meet. These gas pockets prevent full contact and fusion of the melts, resulting in visible fusion marks after cooling. Therefore, we need to design air vents in the area where the melt fronts meet. Through these vents, trapped air and other gases can escape in time, creating favorable conditions for the fusion of the plastic melts, ensuring that the plastic melts are fused correctly without the interference of air pockets, thus effectively reducing the generation of fusion marks. Choose materials with better flow properties and compatibility to enhance flow consistency. Higher viscosity materials are more likely to form fusion lines. In addition, we can consider the use of additives to improve the properties of the material. Flow promoters, for example, can significantly improve the flow of molten plastic, making it easier to combine melt fronts and reducing the appearance of fusion marks. Nucleating agents are also effective additives that can alter the crystallization behavior of the plastic, allowing for more uniform crystallization during cooling, which also has a positive impact on reducing fusion lines. Fine-tune process parameters, increase mold temperature, and delay cooling to buy time for material fusion. Adjusting the holding pressure should not be overlooked. Proper holding pressure ensures that the mold cavity is adequately filled and that the melt is better fused under pressure. If the holding pressure is insufficient, it may lead to insufficient filling of the cavity, which is prone to fusion marks. While too much holding pressure may cause other problems such as deformation of the product. In addition, faster injection speeds can reduce the degree of cooling before the material converges. With a fast injection speed, the melt can fill the cavity in a shorter period of time, which reduces the heat dissipation of the melt in the flow process, making the melt at a higher temperature when it meets, which is more favorable for fusion. At the same time, we can also use simulation software such as MoldFlow and other tools to predict the location of fusion marks. Through simulation and analysis, we can know in advance where and how fusion marks are likely to appear under different process parameters, so that we can adjust the process parameters in a targeted manner to achieve the goal of preventing fusion marks from appearing.